Okay, so today we're going to work on 5.2, which is exponential functions. And a lot of this you've already seen since we did, since we did the parent functions and we looked at exponential functions then. So some of this is repeat. So an exponential function is a function in the form of f of x is equal to a to the x power times b, where a is greater than 0 and a is equal to 1 and does not equal to 1, and b is the initial amount. You guys probably did this when you were in algebra 2, right? So b most of the time is going to equal to 1 in our case, and a is going to be any number raised to the x power. Okay? So here's some facts. Let's see. The domain is all real numbers. Our range is all real numbers greater than 0. There are no x-intercepts because we have an asymptote at y equals 0. And the y-intercept is 0, 1 for every single one of these functions. Just like the parent graphs, we have our essential points. 0, 1 is an essential point. The x-axis is y equals 0. And that is the horizontal asymptote as x approaches negative infinity. Don't worry about this part, but just know that it's a horizontal asymptote. The graph contains the points 0, 1 and 1a. So whatever the base is, for example, if it's 2 to the x power, it's going to be 1, 2. It is an increasing function, so it is 1 to 1. And the graph is smooth and continuous. Okay. So go ahead and take a moment to copy that down. And then we're going to take a look at the graph. So here's a function. Okay. F of x is equal to 2 to the x power. We already know that one of our points is going to be 2 or 0, 1. Right? Because if I plug in 0 here, 2 to the 0 power is equal to 1. And that's always going to be true. And then we said the second point was going to be 1 and then whatever a is. In this case, a is 2. And if I plug in 1 for my exponent, 2 to the first power is 2. So 1, 2. That's how we get that point. And I'm just going to look at maybe a couple more points. If we have x equals 2, 2 to the second power is equal to 4. And if x is equal to 3, 2 to the third power is equal to 8. So our graph looks like this. We know that y equals 0 is our asymptote, so it's always going to get closer and closer to this x-axis, right? But never actually cross it. So y equals 0 is the asymptote. Horizontal. So we know that if we were to do a transformation and we're going to shift the graph up or down, we're also going to shift the asymptote up or down. Okay, so this is what our graph looks like for an increasing exponential function, also known as exponential growth. And if we look at this bottom part over here, all right, and we look at this, our transformations for this case is, first we're going to look at what happens here. So we're going to reflect the graph. It's on the x, right? So we're going to reflect the graph horizontally. Right? And then this one says shift the graph down 3. And if we're going to shift the graph down 3, we also need to move the asymptote. So move the horizontal asymptote to y equals negative 3. Right? I'm shifting everything down 3. Okay? So next we're going to look at exponential decay. Okay, so now exponential decay, if we look at our a, which is our base, that is going to be a fraction. It's going to be between 0 and 1, because we're never going to have a negative base. We can have a negative out front of the base that will reflect it vertically, but not actually have a negative base. So in this case, our domain is all real numbers. Our range is all real numbers greater than 0. We once again don't have any x-intercepts. Our y-intercept is 0, 1, just as before. And our asymptote is also y equals 0. If f of x is equal to a to the x power, right, and it's a fraction, it is a decreasing function, so it's 1 to 1. It's basically exponential decay. So if a is a whole number, it's going to be growth. If it's a fraction, it's going to be decay. It's smooth and continuous, and this graph is decreasing from left to right. Okay? So take a moment and copy that down. And then let's look at this graph. Okay. So if we look at this graph over here, once again, 0, 1 is our initial point, right? Because once again, if I put 1/2 to the 0 power, I get 1. If I get 1/2 to the negative first power, so I have 1/2 to the negative first power, right? I'm going to flip that because I have to make it positive, so that's going to equal to 2. So negative 1, 1, 2, right? And if I have 1/2 to the negative third power, once again, I have to flip the whole thing to make the exponent positive. So actually this is, so if I flip this, I get 2 to the third power, which is equal to 8. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Okay? And if I look at, let's say 1, right? Because once again, we know one of our points is 1, comma, whatever our base is. If I plug in 1 here, I get 1/2. Right? So there. So it's going to look like this. And once again, our x-axis is our horizontal asymptote. Right? So y equals 0 is our horizontal asymptote. Okay, let's see. That's all we need for this part. So copy that down. And now for the last part of the notes. This is the only really new part, unless you guys have done exponent stuff in Algebra 2. I don't know what you guys have covered there. So equations that involve terms in the form of a to the x, where a is greater than 0 and a does not equal to 1, because 1 to any exponent is always going to be 1, so there's no point in the base being 1, are often referred to as exponential equations. You can use the laws of exponents to solve them. So basically, if a to the u power is equal to a to the v, then u is equal to v. In other words, if we make the bases the same, we can ignore the bases and just solve for the exponents. Okay, so let's take a look at a problem like that. So over here, we have 3 to the x plus 1 is equal to 81. And what we want to do is we want to see if we can make 81 into a base 3. Can we do 81 to the base as a base 3? Well, let's do 3 times 3 times 3, which is 27, right? And if I do times 3 again, it's equal to 81. So in other words, 3 to the 4th power is equal to 81. So I'm going to change this to 3x plus 1 is equal to 3 to the 4th power. Now that the bases are the same, I can just solve for this part, right? So now I can say x plus 1 is equal to 4, so x is equal to 3. Let's check that. If I do 3 plus 1, I get 4, right? 3 to the 4th power is equal to 81, so that is correct. So let's look at some more examples. Now, if you guys ever see the letter E, E is just a number, just like pi is, right? So E is approximately 2.7, I think. You could do it on your calculator. So it's just a number, just like pi. okay? So let's take a look at this. We want to make these all into base e. Now all of them have a base e except for this one, because this is 1 over e to the 3rd power. But we can move this up top here like this, right? And change the sign of our exponent. So we get e to the negative x squared is equal to, here we have x, e to the x raised to the 2nd power, so we have e to the 2x, times, here we're going to move it up, so we have e to the negative 3rd power. Okay, now our bases are all the same, except that here we have 2 bases on the same side. We want to make it into just 1 base. So what do you do when you have bases that are the same that are multiplied together? So for example, if I were to have x squared times x to the 3rd, what do I get? I get x to the 2 plus 3, which means x to the 5th power, right? Same thing here. I can make them into a single base, and then I'm just going to add my exponents. So I have 2x minus 3, because I can't do anything else other than that, because they're not like terms. So once again, if the bases are the same, and I'm multiplying 2 bases that are the same, I can just add the exponents, like over here, okay? So now that we have 1 base on either side, we can look at the exponent and just solve for that. So now I have negative x squared is equal to 2x minus 3. I can move this to the other side. I get 0 is equal to x squared plus 2x minus 3. I can diamond problem that, right? I have negative 3 on top, 2 on the bottom. What 2 numbers multiplied together give you negative 3, but add up to 2, and I can say 3 and negative 1. So I have 0 is equal to x plus 3, x minus 1, and then because I'm using the 0 property, I can just solve these separately. So x plus 3 equals 0, x minus 1 equals 0, and here we get x is equal to negative 3, and x is equal to negative or positive 1 right here. So those are our solutions for this. Okay, so once again, I make the bases all the same. This one I had to move up, and by moving it up, it changes the exponent from a positive to a negative. And then I'm going to combine these 2 together, right, by making it to 1 base and adding my exponents. And once the bases are the same, I can now just ignore the bases and just solve for the exponents. And I can plug these in and make sure that they work, which I'm going to trust that they do. Okay, so I want you to take a moment and try these 2 problems, and pause the video, give it a try, and then we'll go over it. Okay? So, let's go over this. Over here, I want to simplify. I have e to the 4th raised to the x power, so I can say e to the 4x, right? Times e to the x squared is equal to e to the 12th. Once again, I have 2 e's over here. I want to make them into a single e. So I'm just going to make 1 base, and I'm going to add these 2 together. So I have x squared plus 4x, and that's equal to e to the 12th. Now that my bases are the same, I can ignore the bases, right? And I can look at these parts right here. So I have x squared plus 4x is equal to 12. I want to move this to the other side, so this side's equal to 0, so I can use factoring to solve it. And now I get negative 12 on top, 4 on the bottom. So if I do 6 and negative 2, that should work, right? X plus 6, x minus 2. And then I have x plus 6 equals 0. X minus 2 equals 0. So over here, x is going to equal 2 to negative 6, right? Because negative 6 plus 6 is 0. Over here, I'm going to get x is equal to 2 because 2 minus 2 is 0. And these are my answers. Okay, so make your bases the same. let's look at this one. So this is a base, we always want to go with whatever's prime. And I can make these into base 2, right? So let's ignore this exponent at the front of this for now. If I just look at 1 over 2, I can change that into 2 to the negative first, right? 2 to the negative first is equal to 1/2. And then I have raised it to 1 over 1 minus x. Does that make sense? By making that into a whole number, I basically changed the exponent to a negative number. And over here, I'm going to have 4. Can I make that into a base 2? And I can do 2 to the 2nd power. Now, I can multiply these out, right, by distributing them. So I get 2 to the negative 1 times 1 is negative 1. Negative 1 times negative x is x. And this is equal to 2 to the 2nd power. So once again, if I look at this part right here, because my bases are now the same, I can now solve for just this. And I get negative 1 plus x is equal to 2, right? And I can add 1 to both sides, and I get x is equal to 3.